Okay, good morning. Welcome to
KidMath number 88.
KidMath number 88. So the other day you asked me a really cool question, and this is our second video in this series, so if you go back to KidMath87, that's the start. You asked me, which has more area? The area inside this parabola, or the area outside the parabola, right?
Yeah.
Okay, and what do you think? What's your hypothesis?
I think they're equal.
You think they're equal?
Because when you extend it for infinity, you get this, the area inside here, this is infinity, and the area outside is infinity.
Okay, all right. So I was actually kind of curious how we're going to start on this, and we talked a little bit about infinity yesterday. And today we're going to do an interesting example that Earl Samuelson from Twitter said would be a great place to start. So instead of the parabola, we're going to look at something just slightly easier that we can get our arms around. You ready for this?
Mm-hmm.
It's this graph. Okay.
It's not a parabola, it's two intersecting lines.
Yeah, so this is the top part of y equals x. So it goes off at a nice 45-degree angle here. And this is the top part of y equals minus x. Okay, so together these are actually the graph of y equals absolute value of x. So like when this is x equals 2, what's the absolute value of 2?
2.
2. So you see that's on the line y equals x.
Mm-hmm.
And when x equals negative 2, what's the absolute value of negative 2?
2.
2. You see that's on the line y equals minus x?
Yeah.
How about that? Okay, so this is actually pretty neat. So we have a pretty simple triangle here. And what I'm going to do is do something kind of fun. I'm going to go to any point here. I guess I can't really call it x, because I wrote those there. This is y equals x. I'm going to write it in here just to get out of the way.
Alright.
And I'll go to some point here, I'll call it z. And I'll go to some point over here, symmetric. It'll be minus z. And I'm going to make this square. So if I'm at z on the x-axis, I go z high. I go z over, z down, z down. So I got a big square whose side length is what?
2z.
2z. Okay. Okay, so do you think this is going to be a 2z over problem? Okay, what's the area of this square?
It's 2z squared. It's 4z squared.
4z squared. So the big area that's the area of everything inside the square. Now let's see if we can figure out the area of this triangle here. Okay, this is a 45-degree angle here, here, and here. So what's this angle on the inside?
That's 90.
Okay, that's a 90-degree angle.
We know this height, this is z.
This height is z,
here.
and how long is this base?
That's also z. It's 2z.
2z. So its base is 2z and its height is z. And what's the formula for the area of a triangle you can write?
It's 1/2 base times height.
Okay, so we get 1/2 2z times z.
1/2 2z times z.
Okay,
So
what's that?
the half cancels.
Yep.
And you get z squared.
Okay, so the area of the triangle here. The big triangle area is z squared. Okay, so when I chop it off into a square, okay, the area of the square is 4z squared. The area of the triangle is z squared. So what's the area outside the triangle?
It's 3z squared.
Okay, so I get z squared here, 3z squared over here. The ratio of the area inside to outside for this shape is 1 to 3.
Yeah.
And then I can start making this square bigger and bigger and bigger, and eventually going all the way out to infinity. Right?
Yeah.
And with my square, I'm always going to have 1/3 of the area in here, and 2/3 of the area. Or sorry, said it wrong. I'm going to have 1/4 of the area of the square inside here, right?
Yeah.
Z versus 4z squared, z squared versus 4z squared. And I'm going to have 3/4 of the area outside, 3z squared.
Yeah, but when the square's area equals infinity, infinity over 4, it's still infinity.
That's true. That's true. That's a very, very good point. But as I go out to infinity, the whole way out to infinity,
Yeah.
the ratio is 1 to 3, right?
So the whole way out, when you keep getting bigger and bigger and bigger, it's the triangle area is still smaller.
Yeah, by a factor of 3, right?
Yeah, but what happens when you get to infinity?
What happens when you get to infinity? Okay?
Hmm.
So that involves a subject in math called limits. And limits come from a subject called
Calculus.
calculus. So I have this calculus book by this guy, Michael Spivak. And I want you, can you read this today?
Maybe.
And understand all of it by
Maybe.
8 o'clock?
Maybe.
Okay? So this is why your question is really interesting. Calculus helps you understand limits like this, what happens out at infinity, and it also helps you understand how to calculate the area for the parabola. Okay? So that's what we're going to do tomorrow.
Alright.
All right? Good job, and thanks to Earl Samuelson for this great idea of simplifying by using y equals absolute value limits.
Alright.
That made it a little easier to start, right?
Yeah.